Hello viewers, how are you all? So myself Nagappa, you are watching Appa Chemistry classes. Now today's topic is single electrode and what is meant by single electrode, what type of single electrode we have, and half cells are what. Okay, those are single electrodes are also called half cells. So we have two types of half cells, metal electrode and non-metal electrodes. And after that we are going to see the electrode potential. What is meant by electrode potential, how that electrode potential is generated in an half cell, how we are going to calculate standard electrode potential, and also what is the relation between Gibbs free energy and the spontaneity of the reaction, electrode chemical reaction, spontaneity of electrochemical reaction, and also most important, the different model problems for calculation of standard electrode potential. Those also we are going to discuss in this video. So don't forget to watch till the end and try to don't skip anything in the video. So each and every point is very important. So I want to waste your time. So let's get into the video. So before this video we had done the galvanic cell, that is electrochemistry part 9. So their galvanic cell clearly I had explained with all the example problems also we had seen in that case. In the representation of cell, those all we had discussed. Now we are going to see the single electrode potentials or half cells. So till now those who not subscribed, please do subscribe and watch Appa Chemistry classes. Now you see here single electrodes. These single electrodes are nothing but what? Half cells. These half cells are mainly two types. By connecting two half cells, one electrochemical cell will be constructed. Now there are mainly two types of half cells are there, that is metal electrodes and non-metal electrodes. So first we will discuss the metal electrode, after that we will come into the non-metal electrode. Now you see here metal electrodes. What is meant by metal electrode here? Now we are taking one electrolytic cell. This is one electrolytic cell. In this electrolytic cell I am taking one electrolyte. So in this electrolyte, which electrolyte you are taking, that respective metal you have to take. Respective metal you have to take. Say for example, you are taking zinc sulfate solution. So you have to take the water zinc rod. You have to take the zinc rod. That is what zinc rod is immersed in zinc sulfate solution. Then it forms the zinc electrode. Okay na? So similarly, copper rod is immersed in copper sulfate solution. Will gives the what? Copper electrode. Similarly, iron rod which is immersed in ferrous sulfate solution, that gives the iron electrode. Now chromium rod which is dipped in chromium sulfate solution, then we will get the what? Chromium electrode, like that lead electrode, silver electrode, whatever the electrode it may be. That is metal rod should be immersed in its metal salt. Okay na? So then we will get the what? Metal electrodes. Now similarly, non-metal electrodes. Now you will get the what doubt here. We have non-metals are nothing but what? These are also called gas electrodes. Now this non-metal electrode, how we can construct? That is most important. You take the what? One electrolytic cell. In this electrolytic cell, you place the platinum wire. Okay na? So it is a platinum rod. So which electrolyte, which electrode you want to prepare? Say for example, I want to prepare the hydrogen electrode. Then what I have to do? I have to take the one inverted tube. That inverted tube contains the platinum rod. That platinum rod is connected to the external circuit. So through this I am passing the hydrogen gas. Whenever hydrogen gas is passed into this, bubbled through this electrolytic experiment. So then what happens here? I want to prepare the hydrogen electrode. So then I have to take the water hydronium ion, that is acid solution I have to take, that is aqueous acid I am taking, aqueous HCl, whose concentration take for example 1 molar concentration, and the gas with pressure is what? 1 atmosphere pressure. With 1 atmosphere pressure, when that gas is bubbled into the electrolytic solution, then what happens? That hydrogen gas is adsorbed on this platinum surface. So when the gases are adsorbed on this platinum surface at 1 atmosphere pressure, that gas electrode, that is platinum rod, it is what? Platinum rod. So this platinum rod is immersed in its respective electrolytic solution. Then that platinum rod itself will act as what? Hydrogen electrode. Is that clear? Now what happens here? We are passing the gas with some atmosphere pressure at atmospheric pressure, that is 1 atmospheric pressure, which is dissolved in its aqueous solution, that is hydrogen generally present in HCl, that is acid solution. That acid solution we have to take. So in that acid solution we are dipping the hydrogen gas. So then what happens? Whenever we bubble that hydrogen gas into this electrolytic solution, some quantity of hydrogen gas is adsorbed on this platinum surface. So this platinum rod is adsorbed the what? Some gases. So this platinum rod is what? It is an inert electrode which does not react with electrolyte. So just platinum rod is adsorbed by the gaseous electrode. Gas. So this platinum rod adsorbed by the gas will act as what? Gas electrode. So if we are passing hydrogen gas, it will act as hydrogen electrode. If you pass the oxygen gas by taking the what? Some electrolyte, hydroxide electrolyte, basic electrolyte, then we will get oxygen is reduced to hydroxide ion. Now chlorine is gas is bubbled in chlorine solution. So bromine solution, bromine gas is bubbled. So in bromine electrolytic solution. So that forms the what? Gaseous electrode. Is that clear? So what are metal electrodes and non-metal electrode? You got some idea. Now we'll see electrode potential. What is mean by electrode potential? How this electrode potential is generated, we'll see. Electrode potential. Now, how this electrode potential is generated in a cell, we will see. Now, this is what zinc rod, which is dipped in zinc sulfate solution. Whenever this rod is dipped in the zinc sulfate solution, there is a possibility of hitting this zinc ions. So, whatever the zinc sulfate solution contain, those will hit with this metal and will bounce back, or they may lose the electron, or they may gain the electron. Any possibility it may be. Or sometimes what happens, the metal which is present, that metal slowly dissolves in the aqueous solution of its own solution. That zinc may dissolve in it. So zinc may dissolve in it. So then what happens, whenever the zinc rod dissolves in its aqueous solution, it loses the electron. So by loss of electron, it converted to Zn+2. There is a possibility. Whenever it is dissolving in the aqueous solution, it releases some quantity of energy in the form of heat. The temperature maybe rises. Okay, na? So these all will be possibilities. Now whenever for example, zinc rod is dipped in the zinc sulfate solution, so which lose the electron. So it converted to what? Zn+2. Okay, na? So then what happens? Electrons are present in the electrode. Okay, na? So what happens? Zinc rod is dissolving in it. So electrons are released. Those electrons are accumulated in the metal rod. Now here what happens, in the electrolytic solution, all the zinc ions will be there. All the zinc ions are developed here. So after some time, what happens? The zinc ions and these electrons in between the oppositely charges. Electrons are negative charges. Zinc ions are having what? Positive charges. These zinc ions, so till how much time it will loses the electron means when the zinc metal electrode reaches its concentration, which is equilibrium with this aqueous solution. So which is equilibrium with this aqueous solution, till that electron go on losing. So after reaching the equilibrium, then what happens? The loss of electron will be stops. Then what happens? Some electrical double layer will be formed between the negatively charged electron excuse me, and positively charged zinc ions. The charge development will take place between this metal electrode and this metallic solution. Then what happens? Whatever the potential which is developed between the metal rod and electrolytic solution, that potential is said to be electrode potential. The potential which is developed around the metal electrode or electrode is said to be electrode potential. So now which type of electrode potential it is? By loss of electron it is taking place. So it is oxidation, loss of electron, oxidation. So which is nothing but what? Oxidation potential we got here. So in the same way, if you are taking here metal, so which is one electrode you are taking, So this electrode, what it is doing, say for example copper electrode. So this copper electrode is dipped in copper sulfate solution. So then what happens to this copper electrode? So slowly it is dissolving, because here electrons are there. So whatever the copper ions which are present in the electrolytic solution, those copper ions gaining the electrons, and will convert it to copper. Then what happens? All the electrons which are present around this metal electrode, all are captured by these copper ions, and they are depositing as what? Copper metal. It is aqueous solution. Aqueous solution containing all copper ions are converted to copper solid. So then what happens? After certain time, it reaches the what? Equilibrium between these two. Now here the metal will not have any electron, because all the electrons are what? Captured by these copper ions which are present in the electrolytic solution. So then what happens? All copper ions are deposited. That metal will not have any electrons. So metal acquires the, that is electrode acquires the positive charge, and electrolytic solution will have the negative ions, sulfate ions, negative ions are there. So in between this negative ion and the metal with positive charge, so between those electrical double layer is formed. Due to that charge separation, some potential will be developed. Which type of potential it is? Gain of electron, that is reduction. So reduction potential is developed. Is that clear? So it is called reduction potential, RP, OP. OP in the sense oxidation potential and reduction potential. Is that clear? So that is what oxidation potential and reduction potential. Have you understood what is meant by potential, how potential is generated? Now here one scientist is there. Okay, now some X and Y, both are the scientist, X, Y. Now X find that zinc electrode potential is minus 0.76 volt. Y find that plus 0.76 volt. They both are fighting and both are quarreling. Mine correct. So whose correct it will be? So both are having what? One X is saying that minus 0.76 volts. Y is saying that plus 0.76 volts. So then both will fight, and they went for the justice. For whom they will go? Where they will go? They go to IUPSC, that is International Union of Pure and Applied Chemists. It is a group of members who gives the solutions for that justice. They will provide the justice. So but they said that both are correct. Whatever the potential you calculated, with all putting all your efforts, both are correct. Now that is what X is saying that minus 0.76, Y saying that plus 0.76. When IUPSC said that both are correct, then they got doubt. So whose is correct? So both are not equal. So whose is correct means? So IUPSC told that it depends on the whether that electrode is gained electron or whether that electrode is lost the electron. That depends. So if it is lost the electron, by loss of electron, you will get the what? Plus 0.76 by loss of electron. That is what we are calling oxidation potential. By gain of electron, so whatever the potential you got, that is what we are calling reduction potential. That is, oxidation potential must be equal to reduction potential with opposite sign. Oxidation and reduction potentials are equal, but they are having the different charges. Their magnitude of charge is different, but their values are same. Is that clear? So now you see here, say for example, the zinc is there. The zinc is losing in 2 electron and it is participating in oxidation. In some other cell, that zinc is gaining 2 electron and depositing a zinc rod. So there what happens? It will undergoing reduction. So that is reduction potential. Oxidation potential and reduction potential will be same with opposite sign. Is that clear? Shall we go to the standard electrode potential now? So what is meant by standard electrode potential? And one more thing here, the whatever the electrode potential is there, no, this electrode, single electrodes mainly depends on single electrode mainly depends on following factors. So what are the following factors right here? First one, so it depends on the nature of electrode. nature of electrode, whether it is metal electrode or non-metal electrode, metal or non-metal electrode. It depends on the nature of electrode. After that, what second factor is what? It depends on the concentration of electrolyte. Concentration of electrolyte. It depends on the concentration of electrolyte. Third one is temperature. It depends on the temperature. And fourth one is, if it is in case of non-metal electrode, that is gaseous electrode, it depends in case of gas. In case of gas electrode, it depends on electrode potential. Single electrode depends on the pressure. In case of gas electrode, it depends on the pressure. And also, it depends on the number of electrons. Number of electrons lost or gained. Number of electron lost or gained. Is that clear? These are the most important four factors which affect on the single electrodes. Is that clear? So next we will see the next one. We'll see the standard electrode potential. Have you understood what is electrode potential, how it is generated? So the electrode potential will be what here? The potential which is developed at the electrode between the, when electrolyte is equilibrium with its metal electrode. So whatever the potential which is developed, that potential is said to be what? Electrode potential. Now we will see the standard electrode potential. Standard electrode potential. What is meant by standard electrode potential? The potential, it is standard electrode potential is represented with E naught. Okay na? So E naught of cell, standard electrode potential of a cell. It is represented with E naught cell. Now what is meant by standard condition? Standard condition is nothing but the potential. The potential is E cell. E cell is nothing but what? Electrode potential at 25 degrees Celsius or else 298 Kelvin and 1 atmosphere pressure. 1 atmosphere pressure. And the electrolyte concentration should be 1 molar concentration. 1 molar concentration. The electrode potential which is measured at a standard condition, that is 298 degree Kelvin and 1 atmosphere pressure and 1 molar concentration of electrolyte, and the metal and its metal ion are in equilibrium with one another. So then whatever the potential which is developed, that potential is said to be what? Electrode potential. That is a standard electrode potential. Is that clear? So standard electrode potential is nothing but the electrode potential which is measured at standard condition when metal electrode is in equilibrium with its electrolytic solution is said to be what? Standard electrode potential. Is that clear? So that is standard electrode potential. So now how to calculate anything standard electrode potential? For example, my weight is 100 kg. How I am calculating? With reference to weighing machine or with reference to weighing whatever the bots or weighing weighing bots. With respect to the weighing bots, I am saying that my weight is 100 kg. That is weighing bots are what? If I am placing that side 100, I am standing here means both are equal means my weight is what? 100. That is what, with reference to that I am calculating. Here also we cannot calculate single electrode potential. So we should have some reference electrodes. So those reference electrodes are said to be standard hydrogen electrode. It is what? SHEC. Okay na? So it is standard hydrogen electrode. The standard hydrogen electrode is primary reference electrode. Standard hydrogen electrode. Standard hydrogen electrode is the primary reference electrode. It is what? A primary reference electrode. Why it is taken as primary reference electrode? Because its electrode potential is taken as arbitrarily, it is electrode potential is taken as 0. So that is the reduction potential of standard reduction potential of hydrogen. It is what? H plus to H2, that is nothing but reduction potential. So H2 to H plus, that is platinum we have to write. Gas at 1 atmosphere pressure. So both should be equal, is equal to 0 volts. So for that reason, it is taken as what? SHE or normal hydrogen electrode. It is also called normal hydrogen electrode. So whose electrode potential is taken as 0. So then it comes under what? Primary reference electrode. It is taken as primary reference electrode. We have secondary reference electrodes like Calamol electrode and twin hydrogen electrode. Okay, gas electrodes we have. Okay, so but whereas this primary reference electrode is most preferred one when compared to standard hydrogen electrode. If they are having reduction potential value is more, then what happens? They act as cathode. When compared to the hydrogen electrode potential, they are having a least reduction potential values, then they will act as anode. Is that clear? So with reference to that standard hydrogen electrode, we are going to calculate the electrode potential. Just now I told you what is how we are getting a hydrogen electrode. You can take this one. So here what we are placing the platinum rod, so which is having the, now here, so we are bubbling the hydrogen gas with this. Hydrogen gas is bubbled with 1 atmosphere pressure. So we have the electrolyte here. We have electrolyte is there. 1 molar electrolytic solution we are taking. So at 298 Kelvin, whatever the potential which is developed at this electrode and this electrolytic solution, both will have the what? Equilibrium. When they reaches the equilibrium, the whatever the potential which develops, that is what we are calling standard hydrogen electrode potential. Now electrode potential is calculated. Now this is one half cell, this is another half cell. So now this is one electrode, this is another electrode. These two are connected with a salt bridge. Okay, so these two are connected with a voltmeter or ammeter. Okay, now to calculate the, now here it is what? Anode. Now it is cathode. In the last class we had discussed. Now here what happens? Electrons are moving from this direction. Electrons are moving in this direction. So current will move in this direction. So current will move in this direction. Is that clear? So that is the flow of current. Now how you will get a standard electrode potential of a cell? You will get the sum of the potential. That is, at anode what happens? Oxidation takes place. Oxidation takes place. At cathode what happens? Reduction takes place. Okay, na? So then what happens? Sum of the oxidation potential, sum of oxidation potential plus reduction potential. Okay, na? Oxidation potential and reduction potential will gives you what? E0 cell. Is that clear? Here E0 cell is what? Sum of the oxidation potential plus reduction potential. But what they said, IUPAC said that you try to take always, we have to consider the reduction potentials. If you are taking the reduction potential, we know that what? Oxidation potential is equal to minus of reduction potential. Is it or not? So that is here what happens? In place of oxidation potential, you can convert into reduction potential. Both are having same value. Then what happens? It will be, so E0 cell becomes, it is what? Oxidation potential which takes place at anode and reduction takes place at cathode. It becomes minus value. Okay, na? So then what happens? We can call it, we can take it as reduction potential, that is reduction potential at cathode minus oxidation potential, that is reduction potential at anode. That is, here it is what? Reduction potential at anode. Now you see in this electrolytic cell, these are the two half cells. So anode is where it is on left side. So standard reduction potential can be calculated as cathode is present on your right side. So that right side minus E right minus E left. E right minus E left. When we have to consider this one, when we have to consider these two formulas, when they given the reduction potential, when they given reduction potential, we have to take this one. If they had given specifically, they mentioned oxidation and reduction potential, we have to take this one. If they are asking to calculate oxidation potential, in terms of oxidation potential, what happens? E0 cell is equal to E left minus E right. E left minus E right. That is left side is what is there? Left side is what? Anode. Anode electrode potential minus cathode electrode potential. So it gives you what? Standard electrode potential. So this when we have to consider this one, when they given oxidation potential. When they given oxidation potential. Is that clear? So most important when we have to consider. Now what is the relation between this electrode potential and Gibbs free energy? This is what Gibbs free energy, change in Gibbs free energy is equal to minus N into F into E naught cell. So we had seen that F is what? Faraday constant. So here E naught cell is what here? Electrode potential, standard electrode potential we will calculate here. So what is N here? N is number of electrons exchanged. N is number of electrons transferred from anode to cathode. Number of electrons transferred from anode to cathode. How many number of electrons are transferring? Is that clear? So that is delta G is what? Number of electrons transferred. Now when the cell reaction will be spontaneous, when the cell is takes place spontaneously, when E naught cell should be what? Greater than 0. That is the standard reduction potential value, the standard electrode potential should be positive. And Gibbs free energy, what happens? E naught cell is positive means it becomes what? Negative. Gibbs free energy is negative means it is said to be what? Spontaneous. So that we had discussed in case of thermochemistry. Okay, na? Their standard Gibbs free energy. Standard Gibbs free energy is nothing but it is a useful energy which is converted in the form of work. The useful energy which is converted to work. Okay, na? Delta G is equal to what you can say? W useful work minus W useful work. Okay, na? So that is free energy which is utilized for the doing of some work. Is that clear? So that is by using that formula we can decide whether the reaction is spontaneous or not. Okay, now that spontaneity, those all we'll discuss there in thermochemistry. Just you do remember here, delta G value is negative means it is a spontaneous. When it will be negative? When electrode potential is positive, then delta G is negative. Is that clear? We'll see some problems. We'll see the problem here. These are the some model questions. To calculate the electrode potential, standard electrode potential we are calculating. You do remember that here temperature and concentration of electrolyte will be remains constant. Is that clear? So that is most important here. Okay, na? So now you see in this case, this is electrode cell. It is cell representation. They given the electrode potential of silver. They given standard reduction potential +1 to Ag plus 2 Ag. Gain of electron, that is reduction potential they given. Reduction potential they given. When they given reduction potential, how to calculate standard electrode potential? That is E right minus E left. Is it or not? That is what E right minus E left. E right in the sense what? Cathode. Anode. Okay, na? Cathode potential minus anode potential. Now what is which is acting as cathode here? This is a cell representation. So which is present on your left hand side? Nickel. That nickel will be what? Anode. This is what? Anode. In the last video I had explained you how to write the cell representation and cell reaction also. It is what? Cathode. So left side whatever it is there, anode, right side cathode. Okay, na? So now E naught cell is equal to what happens? The right side which is there, the silver, what is its potential? 0.30 minus of anode potential is how much? Minus 0.25. So what is the value it is? You add it, you will get the plus 0.55 volts. That is E naught cell. Standard electrode potential of that cell reaction will be plus 0.55. Now coming to here. So this is cell reaction whose electrode potential, that is zinc electrode potential, they given minus 0.76. Which electrode potential it is? Reduction potential. That you need to identify. First thing, whether they given reduction potential or oxidation potential, that you need to identify. Copper +2 to copper. That is by gain of electron. Reduction potential they given. So E naught cell is equal to, that is E right minus E left, simple one. That is, which is having anode here, this is anode. So anode is present on your left hand side. On right hand side, which is there? Cathode. Okay, na? So which is present on right hand side. So E right, copper ion is what? 0.34 minus of minus 0.76 volt. So by adding these two, you will get plus 1.10 volts. That is galvanic cell or voltaic cell. Daniel cell electrode potential. Now next here it is what? In this case you observe here clearly. What they given here? Which potential they given? Oxidation potential they given. Okay, na? So you do concentrate here. What potential they given? We have to observe clearly. So they given oxidation potential. Here also oxidation potential. When they given oxidation potential, what is the cell reaction here? Standard electrode potential is equal to what is that? E left minus E right. E left minus E right. What is left side? Anode. So anode potential minus cathode potential. Okay, na? So what is anode potential here? Which is anode here? This one is anode. Zinc is anode. That is plus 0.76 minus 0.13 volts. That is cathode. Okay, na? So cathode is what? This one. Cathode. It is anode. So anode potential is how much they given? We converted it is. We had not taken the E right minus E left. If you want, you can convert into by multiplying with minus and substituting. You will get the same value. In that, no doubt. Minus plus 0.76 minus 0.13. It becomes what? Plus 0.63 you will get. That is what? Electrode potential. Standard electrode potential. When they given reduction potential, how to calculate? Oxidation potential, how to calculate? I had explained you. Now coming to here, standard free energy. They are asking to calculate what? Standard free energy and predict the feasibility of a cell. Whether that reaction is feasible or not. First thing, we should know the what? E naught cell value. That is electrode potential we should know. Standard electrode potential. How you will get it is what the values they given? Reduction potential or oxidation potential. Zn plus 2 to Zn means reduction potential they given. That is what? E cathode minus E anode. That is E right minus E left. E right minus E left. Now right electrode potential. That is nothing but what? Cathode potential minus anode potential. So which is anode here? This one is anode. This is cathode. Now they given cell reaction. Cell representation they given. So you see here in every case they are mentioning 1 molar means standard condition. In standard condition only we will calculate like this. If they are asking a variation in concentration and temperature, then we have to follow the Nernst equation. Next after this you will get. So that is E right. Which one is right? This one. Copper electrode potential is plus 0.34 minus of anode potential is how much? Minus 0.76. So minus of minus plus it becomes 1.10 volts. Electrode potential is what? E naught cell is positive. E naught cell is positive. Then delta G becomes what? Negative. Delta G is negative. Then it is a spontaneous. Gibbs free energy is negative. Then it is said to be what? A spontaneous reaction. Now how to calculate Gibbs free energy here? Delta G is equal to minus NF E naught cell. Now how many electrons are transferring here? 2 electrons from zinc to the copper. That is what? Minus 2 into Faraday constant 96,500 coulomb into E naught cell. So Faraday constant, those who not understood, you can watch the part 7 electrochemistry, part 8 I think, part 8 only. Faraday's second law, detailed explanation is there with more number of problems and easy how you are going to calculate the values. So E naught cell is how much? 1.10 volts. So you do this calculation, you will get the standard Gibbs free energy in terms of negative values. Okay, now that is Gibbs free energy. Next here, if they are not given the cell representation, they are given like this. So how to identify which is undergoing oxidation, which is an anode and which is an cathode, which undergoes in oxidation, that is taken as what? Anode. Generally, always in electrolysis process or in electrochemical cell, oxidation takes place at anode, reduction takes place at cathode. Is that clear? Now you see in this case. So this nickel is oxidizing and hydrogen ion is reducing. That is nickel electrode is what? Undergoing oxidation. So hydrogen is undergoing in reduction. So E cell, first we will calculate E naught cell, that is they given the what reduction potential, that is E right minus E left. E right is what cathode, that is 0 minus of 0.25. So that is what plus 0.25 volts. Standard electrode potential of this cell reaction is how much? Plus 0.25. E naught cell is positive, means delta G is what happens here. E naught cell standard electrode potential is positive, delta G becomes what? Negative. So it is a spontaneous process. Is that clear? So how to calculate delta G? Same formula, minus NF E naught cell. Okay now. So what is the N value here? It is losing the 2 electrons. The last 2 electrons are gained by the hydrogen ion. That is 2 into 96,500 coulombs into E naught cell will be what? 0.25. Will get in joules, that you convert into kilojoules. Generally they will ask in Gibbs free energy in terms of kilojoules. Okay na? So is that clear this? Now simple question I will tell you whether this reaction is spontaneous or not. Now I am taking the water copper sulfate solution. Copper sulfate solution. So this is copper sulfate solution. In the starting of the class, that is before the galvanic cell, I had explained you. This is what zinc rod. Whenever zinc rod is placed in copper sulfate solution, what happens? Zinc rod is placed in copper sulfate solution. What happens? Whether this reaction is spontaneous or not. If you want to stir this copper sulfate solution with zinc rod, is that correct process or not? It is an incorrect process, because the zinc rod is what which slowly react with copper, because it is a more reactive one. So which has the what more reduction potential. It has the least reduction potential when compared to copper. So then what happens? It react with copper and the blue color will be fades away. Blue color is fades away. Even we are getting a standard electrode potential will be plus 1.10 volts only. So by seeing this, Gibbs free energy is what? Negative. So it is a spontaneous process only. But what happens actually? It is spontaneously takes place, but it is not the correct process, because when the zinc rod is placed here, the copper sulfate will be changes to zinc sulfate. Okay na? So that is one of the application related question. So I hope so you have enjoyed a lot. So in this video we had seen electrode potential, standard electrode potential, how to calculate standard electrode potential, those all we had seen. I hope so you have enjoyed a lot. So those who, and here you need to understand the concept and you note down all those problems. Definitely you are going to crack the NEET and mains. Thank you. Have a nice day. Keep watching Upper Chemistry classes.